right, continuing on with our light bulb example here. In question E, we are asked how long a bulb will last if it's in the 95th percentile of the lifetime of all bulbs, okay? And it tells us to draw and shade our normal curve. So when I've got my curve here, remember the 95th percentile means 95% of the area is going to lie at or below that value, okay? So here's the region that we're looking for. And this part right here, this is 95% of the area, okay? The mean is still here at 1550. And what we're looking for is this 95th percentile, and we want to know what value that happens to be, okay? What is the value? How many hours is that? Okay, that's what we're trying to figure out. So how is that different from the previous problems? Okay, so this time we have the area, or the percentile. Remember, those are the same thing. Okay, area is probability. And we need to find the number of hours. Okay, so we don't know the number of hours. So before we knew how many hours we were finding that probability, this we've kind of flipped that on its head. Okay, so how does this change the procedure that we need to use in order to solve this problem? Well, it changes it in one pretty big way. Okay, when we need to find an x value, we are going to invert the normal CDF. Okay, and you have a function on your calculator that does that in the exact same place, probably right below your normal CDF, and it is INV, so for inverse or invert normal. Okay, and then for those of you, again, without prompts, okay, those of you with prompts, this will be a slightly different procedure. Those of you without prompts, this is going to be the area from the left. So starting all the way down at the left end of the curve, okay, how far up, how much area do you need? Then your mean and your standard deviation, okay? Those of you with prompts, you'll see exactly what I'm talking about as we go through this, okay? So how long will a bulb last if it's in the 95th percentile? So we're trying to find an x value. So this will be, use our inverse or invert normal, okay? Those of you without the prompts, so the area from the left, so starting all the way down here up to where we want to stop, that's 95% of the area. Enter that as a decimal. Our mean, still 1,550 hours, and our standard deviation of 57. Now, those of you with the prompts, you will probably notice that it said on your calculator something like area, you put in 0.95, then you've got your mean of 1,550 and your standard deviation of 57, and then it says tail, left, center, or right. Well, we have the whole leftmost portion from this line here that we drew, this line here that I'm drawing an arrow to, okay? From there down, we have to the left. So highlight tail for left, and then go ahead and paste your answer, okay? You will find that this is 1,643.8, and that does have units. This is hours. So in other words, we expect 95% of light bulbs to last that many hours or less, okay? All right, so kind of piggybacking off of that one, how long will a bulb last if it's in the 45th percentile for the lifetime of all bulbs? So here, with our 1,550 hours in the middle, we're looking for the 45th percentile. So that's going to be a little to the left of 1,550. Remember, half of our area falls to the left of our mean. Okay, so we're looking at this portion here having 45% of the area. So we're going to, again, we want to figure out what that value is right there. That's our 45th percentile. So we want an inverse normal. 0.45 is the area from the left. Our mean of 1550, our standard deviation of 57. And you should end up with 1,542.8 hours. And notice that is just a little smaller than our 1,550 hours that we expected. Okay, going on to example G. And this is just for the people who have the calculator with prompts. If you do not have prompts, stop the video now and go check out the next video, because I'm going to specifically explain to you how it is you need to do this problem. Okay, so those of you with prompts, let's continue on real quick here. So find the two values between which 60% of the light bulbs, or the lifetime of all bulbs, will fall. Okay, so here's our 1550 in the middle. And when it says between which 60%, you're really at that point talking about the middle 60%. Okay, we're talking about the middle 60% of the area. And so we need two values. We need to figure out what this X value is right there, and I'm going to label this one as a Y value. We need to figure out what that Y value is right here. Okay, so on your calculator, you can do your inverse normal. You can type in your area of 60%, your mean of 1550, and your standard deviation of 57. And as you might suspect, this is the perfect time to select center when it says tail, because you are looking for what that area is in the center. Okay, as you do that, you're going to get two different values reported to you. Okay, so you're going to do your inverse normal. You're going to have your 0.6, your 1550, 57, maybe STR for center. You're going to get two different values out. On the low end, rounding to the nearest tenth, you will get 1502.0. And on the upper end, you will get 1598.0, also rounding. Okay, and so that means the middle 60% of light bulbs will last from 1502 to 1598 hours. Okay, and that's all you need to do is tell it you want the center, and it will calculate both of those for you.